Okay, so here we go. We are going to do these 4 little problems here called quick review. Okay? Quick review. Here we go. First one. Yeah, Branson's giving away the answer already. It says, write the equation of the linear function where f of 2 is 1 and f of 3 is -2. So, what does that mean? Write the equation of the line. So, like Brenton said, oh, wait a minute. What does this mean? 2, 1 and 3, -2. Remember, the function notation is just a fancy way of writing an ordered pair. So our slope is 1 minus -2, 2 minus 3. I got -3. Did I do that right? Mm-hmm. Okay. So then somehow, whether you use point slope or slope intercept is completely up to you, but somehow we want to come up with an answer that is -3x plus 7. I did my arithmetic correctly. That's easy. Number 2. I think this was on a quiz also. We want to write the equation of the quadratic function. What does that mean? Quadratic function. That means it's x squared. It's a parabola. So we're going to write the equation of the parabola with a vertex at -1, 4 and containing the random point 3, 5. So what's our strategy on this?
Well, you can write y equals n parentheses x minus 1 plus 1.
There are actually 3 places for numbers in the equation. There's a number out front, there's a number in the parentheses, and there's a number on the end. And here tells you where the vertex is.
Yes.
So since our vertex is at -1, this has to be x plus 1. 4, this would be plus 4. Remember, that tells me that my parabola has been moved 1 unit to the left and 4 units up, which puts it at that vertex. Now, how do we figure out this number?
You plug in the 3.
I put 5 in for y and 3 in for x. And I'm careful when I do my arithmetic. 3 plus 1 is 4, squared is 16. I don't add the 16 and the 4 because the 16 is connected to the n. So I'll bring the 4 over. Whoops. And so n equals 1/16. And that would be the equation of my parabola. Remember doing that? Yeah. Easy. An object is thrown, so its height is given by this equation. So this is the height. Call it h if you want. When does it hit the ground? How do I figure that out?
Do you find the 0?
Yeah, because what do you know about it if it's hit the ground?
0.
You know its height is 0. When you look at an equation, kids, you've got to pay attention to the variables. It says the height at time t. So when is the height 0? When it's on the ground, right? So when is that? Well, let's just solve this. That factors. So it's on the ground 2 times. It's on the ground at 0 and it's on the ground at 5. Does that make sense? On the ground when you threw it, and then it goes up and comes down and hits again. What is its highest point, and when does it reach its highest point? Okay, what shape is that equation right there? That's a parabola opening down. -4, down. So if we want to know its highest point, what are we really looking for?
The vertex.
The vertex. So you can complete the square or just do -b over 2a. Here's my equation. So -b, actually it's t, -b over 2a would be what? 2.5? Now, I think you could figure that out without doing that work, because think about this problem right here. When was the ball on the ground? At 0 and at 5?
So you just find
So when is it going to be at its highest point?
2.5.
2.5. Doesn't that make sense? So, the question that says, when is it, or when does it reach the highest point? The answer is 2.5 seconds or minutes or whatever the time is, we don't know. Now, what is the highest point? How would we figure out what is the highest point? Plug in 2.5 into our equation. So 20 times 5/2 squared, I'll do it in fraction form since I'm not using the calculator. Oops, that's not squared. 20 times 5/2 minus 4 times 5/2 squared. Okay, so that's 50 minus, that's going to be 25. So I got 25 feet or inches or whatever the unit is. Is there?
I got 25.
Good. That was pretty easy. Rate is inversely proportional to time. All right, stop right there. What general formula pops into your head when we say rate is inversely proportional? Y equals K over X. That's inverse variation, inversely proportional. Rate, so this is the formula. For this particular equation, rate is inversely proportional to time. Instead of Y's and X's, we'll use R's and T's. Rate is inversely proportional to time. So there's your equation. Now, how am I going to find K if R is 60 and T is 2? Plug it in. So R is 60 and T is 2. So what's K? 120. Easy, easy, easy. All right, let's look on the back side of this. There are a couple of extra word problems on the back side of that paper. Okay, so let's look at number 2. We've done a lot of box problems like number 1, but let's look at number 2. Problem number 2. Okay, so we got super duper ping pong balls, and we know the supply is 4 plus 0.01 p squared. All right, that's given. We don't figure it out. We know the demand is 35 minus 0.002 p cubed. Those of you that are working on your homework know there's something like this in the homework. P is the price of each ping pong ball. Determine the price for which supply equals demand. So what are you going to do? Set them equal to each other. So 4 plus 0.01 p squared equals 35 minus 0.002 p cubed. Now, this is going to be a calculator problem. So at this point, you have a couple of options. Okay? One option would be to graph this as like y1, one equation in your calculator, y1 equals, and then graph this as a separate equation, and look for what when you graph them? Where they intersect. And then you'll go to second calc and pick the intersect option, right? Then you have to set left bound, right bound, all the same stuff. Another option would be to get the whole thing set equal to 0. So in other words, just move things around. So the whole thing is equal to 0. And then graph that. But if you were graphing that, what would you be looking for? The zeros. So graph this picture and look for where it crosses the x-axis. Now, keep in mind for both strategies, whichever one you choose, and if you did it this way, you'd still go to second calc, but instead of choosing intersect, you would choose zeros. But no matter which way you do it, be careful. I don't know what the p-values turn out to be, but remember, it's a price. So negatives aren't going to work, right? So if you've got negative places where they intersect or negative roots, you have to throw those out because they wouldn't work. All right, so quickly I'll type that in. We'll see what the answer is because I don't think I have answers to this paper. Although maybe I do. No, I don't. Okay, so I'm going to graph this thing. Yeah, my window's set, so we'll just see what happens. Nothing. Okay, I need positive. So mine came out to be, I'll tell you here in a second. I got a picture finally. So my price came out to be 23.37. So $23.37 is the price. So they should be intersect. If you're doing the intersect method, this should be your X value. So make sure your window is big enough for that. If you're doing the zeros method, which is the way I did it, the window I used was 0 to 50 and negative 10 to 10, and that did it for me. All right, so that's not too bad. All right, let's see about the next one. Gabby's Spanish book is thrown vertically upward. Initial velocity, approximate height of the ground is given by this equation. Okay, so there's the equation you've been given. Both these problems you were given the equation, so you didn't have to even find it. When does the ball reach its maximum height? What is the maximum height? When does it hit the ground? Okay, we just answered those questions. How are we going to find when does the ball reach its maximum height? Maximum height would be vertex. T equals negative b over 2a. So when does it reach its maximum height? About 2.5 seconds, or a minute, whatever the time thing is here. Yep, 2.5 seconds. What is its maximum height? So now we just plug it in. We're going to find S of 2.5. So we'll just plug it in. And I got 30.625 meters. When does it hit the ground? Well, one surefire way of finding out where it hits the ground, kids, is to set it equal to 0 and solve it, right? So if I take out a t, I'll be left with 24.5 minus 4.9t. So one time it's on the ground is at 0. The other time it's on the ground is at 24.5 divided by 4.9. 5. Brenton, I think you said that.
Well, all I did was do 1 times.
Yep. That's perfectly logical. Now, the only time that isn't going to work, Brenton, be careful,
Okay.
is if the object is not thrown from ground level. Okay? Because then the high point will not be the middle of 0 and something else. It won't be half of this.
Okay.
It'll be the midpoint of these two, which you don't know what those things are. Okay? But as long as there's no initial height, remember this equation? It has this, and then it has the initial velocity and the initial height. As long as there's no initial height, as long as it's starting at 0, you're always going to be double the vertex when you're in on the other side. Okay, that wasn't so bad. Number 4. Got a textbook company with 200 books ready for sale. And the price per book is 80. So our revenue or income is starting out as 200 times 80, right? But what are we doing?
Each price.
We're changing some things. And we're doing it incrementally, right? So what is the increment for the number of books sold? Up 12? What is the increment for the price? Minus 4? So that's the increment. So every time I drop my price, it's going down by 4. Every time I sell more books, it's going up by 12. All right, so how do I express that as an equation? 200 plus 12x and 80 minus 4x. Now, some of the classes had this problem on their quiz. The quiz you just took, you didn't, but some of them did. And some kids were putting like plus here and plus here. Will that ever happen? No, because when you talk about price and demand, the number you sell, if the price goes up, demand is going to go down. If price goes down, demand is going to go up. That has to happen, you guys, because when you FOIL, you have to get a negative x squared. Why do I have to get a negative x squared? Because the problem is asking me for a maximum. If I had a positive x squared, what kind of picture would I have? Does this have a maximum? No. It goes on forever and ever, so you need a negative x squared. Okay, so what do we do next? I want to get to some more problems. I think we can finish this. Well, maybe we can. Maybe we should finish it. All right, so we FOIL it out, and hopefully I've got my arithmetic going well. I have no idea if I do or not. I'm trusting that you'll correct me. So I just FOILed. Anybody confirm that before I finish the problem? Another 0 where? Here?
On the bottom.
Oh. Here. Yeah, there should be. Yep. Right there. Should be. Thank you. Now, I'm lucky because I'm getting ready to find the vertex. Right? And if all I need is the x value, that wouldn't have hurt me. If I need the y value, it would. So let's see what we need. The vertex is going to be x equals negative b over 2a, which is, I'm sure, something I got 5/3. 1 1/3. Okay, now, is that 5/3 dollars? 5/3 books? What is that 5/3?
The price they should charge. Oh no, how many times you want.
How many times I'm going to change the price?
Yeah.
Now, I'm going to change the price 5/3 times, and every time I change it, it goes down 4. So I'll take that number times 4, and that means I'm going down a total of $6.67 from an original price that was 80. So the price I charge is $73.33. That's what I should charge for my books. It's going down 5/3 times. Every time is worth $4. So 4 times 5/3 tells me how much it's going down from a price of 80 to start with. And then finally, we're going to enclose the backyard, maximum area, one side of the pen will be his house. This is your quiz question. All right, do we know the dimensions here? Do we know what these are? Nope, so let's call one of them X. What would the other one be then? Keep in mind that you only have 240 feet of fencing. So what would this be?
240 minus 2x.
240 minus 2x. Because you had 240 and you put an x here and an x here. All right. Now what are we trying to do? Maximum area. How do you find the area of a rectangle? Length times width. So I have 240x minus 2x squared.
Yep.
What do I want to do with that area? Maximize it. Find the maximum, which means vertex. Negative b over 2a. I got 60. Now what is that? What's the 60? Is that the answer to the question? That's the size of this side of the pen. So what would this side of the pen be? 120. What is the maximum area? 120 times 60 will be the answer to the question. That is your maximum area. Okay, the fun just never ends, people. I need you to go to the very last page of your packet. And I want you to look at the side. It's like 3 pieces of paper all stuck together. And it says additional review. It's the very last paper. And the front of it says, you have to look at it sideways here, but it says Precal A additional review for test. That's what we're looking at. Now, some of these we've already done, so I'm not going to work through the whole thing. Look at number 1. Have we already done one like number 1 today?
Yes.
Yep. What's our strategy? Read the problem. Make sure you understand what the problem's asking you. What is your strategy? For problem number 1. Set them equal to each other. So 0.003 p cubed minus 0.04 p plus 1 equals negative 0.04 p squared plus 2p. Griffin Spurgeon, you with me?
Yep.
Now, what are our strategies? I'm not going to do this when you have the answers to this, but what are the strategies? You have a couple of options. What are they? You could move everything over, set it equal to 0, and if you did that, you'd go to second calc 0, because then you'd be looking for the x-intercepts. What's your other strategy? Graph both of them individually as two separate equations and look for where they intersect. You're still going to second calc, but you're going there for intersect now instead of 0. Okay, that's easy. Number 2, find the nature of the solutions. Okay, this is good practice. This is DesCartes Rule of Signs. Did we talk about this the other day?
No.
We haven't talked about DesCartes Rule of Signs? Oh, goodness gracious. Okay, well, let's talk about it right now. And then somebody needs to remind me at the next class to do more practice problems, because we're only going to have time for this one. All right, so DesCartes Rule of Signs, this is kind of abbreviation here because I thought we'd done it. It gives us the number of positive real roots, the number of negative real roots, and the number of imaginary roots. So DesCartes Rule of Signs is another tool, just like the PRRs, that sometimes can save you time and sometimes it doesn't. Now I know when I look at this problem that it has 10 answers. Some of them are real, some of them are imaginary, some of them are negative, some of them are positive. I have no idea, and we're not going to find them. We're just going to talk about what kind of numbers they could be. So, to find the number of positive real roots, you simply look at your problem and you count the times the sign changes. So what I mean by that is, this term is positive. This term is negative, so that's a change. I went from positive to negative. Uh-oh, what happened? I went back to positive, so that's another change. Now I stayed positive, but then I went to negative. So how many times did my sign change? 3. Now does everybody understand how I got the 3? So, positive real roots, 3. There were 3 sign changes. Here's the tricky part. DesCartes was a really smart guy. There are 3 sign changes or 1. We count down by 2s. Now I'm not going to go into a big explanation because you don't care anyway probably, but remember the other day when we talked about imaginary roots? What did we say about that? Can you ever have just 2 plus I? No, you would need to have 2 minus I. So that phenomenon, the fact that complex roots must come in pairs, means whatever you're counting is going to count down by 2s to accommodate that. So what this means is, if you actually solved this, which we're not going to, but if we actually solved it, there will be either 3 positive answers or just 1 positive answer. I don't know. I said this is a tool. Sometimes it helps, sometimes it doesn't. There's either 3 or 1.
So if you got 5, would it be 5 or 3 or 4?
It sure would be. You count down by 2s until you can't count anymore. So if there had been 4, it would be 4 or 2 or 0. You keep counting down by 2s, however many sign changes you had. Now, we're going to do exactly the same thing here. Okay, exactly. Except, we're going to pretend x is a negative number. So pretend x is a negative number. Would this term be positive or negative? You guys, if x is negative, what happens when you raise it to the 10th power?
It becomes positive.
Yes, this term is still positive. What if x is negative here? It will become positive, right? What if it's negative here? Positive. What if it's negative here? Negative. And that's an 8. That's going to stay negative. So looking at those terms, how many sign changes do you see?
Just one.
Just one. So that's just one. You can't count it down, it's just one. Because the sign only changed one time when x was negative. Now how many roots did we say we were going to have altogether? So now we're going to use our logic. If 3 of them happen to be positive, and you have this one negative, how many would be left to be imaginary? 6. But what if 1 is positive and 1 is negative? Then there would be 8. Are there any other options? No. You're either going to have 3, 1, and 6, or you're going to have 1, 1, and 8. Now, as it turns out, I got time to do another one, and I will, but I want to make one more comment. See these 2 down here? They have to be even. Whatever numbers you put down here have to be even. Why do these have to be even?
They come in pairs.
They come in pairs. So if you do this and you get a 5 down here, you've messed up, because that's not possible. All right, let me do one more quick example. Make sure you got this. It's real easy. Let's say you have to find the nature of the solutions of 3x to the 15th minus 4x to the 5th plus 9x squared plus 8x plus 7. Okay, here we go. We want the nature of the solutions. Which is how many positive reals, how many negative reals, and how many imaginaries. Now I know we just talked about this like 3 minutes ago, for the first time, so you may not remember, but does anyone remember how we start this problem? How do we find the number of positive roots?
You look at the changes.
I look at the original problem, right here, and I say, okay, I gotta change here,
There's nowhere else.
I gotta change here, and that's it. So there's 2 of them. What, the positive, the negative, the positive, right? So what do I write here? 2 or 0. You count down always by 2.
See? Zeros.
Wait, you said there was, okay, yeah.
2 or 0. So now I'm gonna let x be a negative number. Now, if x is negative,
Just negative.
that'll be negative. If x is negative, that'll be positive. This one will be positive. This one will be negative, and that one is, of course, positive. So how many changes did we get?
3.
1, 2, 3. So that's 3 or 1. All right, so now we got to consider all the possibilities, okay? So logic. 2 and 3 would leave,
12.
how many are there? 15. If you have 2 and 3, then you only have room for 10 more. What if you have none in 3?
7.
No, there's 15. So if you have none in 3, that would leave room for 12. What if you have 2 and 1? That would leave room for 12. I don't have to write it again. What if I had none in 1?
14.
That would leave 14. Notice that bottom row is all even, which is exactly the way you